Hello, pre-calculus students. This is Mr. McAllen, and today we're talking about how do we find a trig function from data. So what I have is I have a table of data, which we're going to plot on an XY graph, and then we're going to draw a trig function through the data and come up with what the sine function would be. So I'm going to plot this data while I pause the video, and then when we come back, we'll actually talk about how to fit it. Um, so I'm just going to pause the video while I plot the data, and then we'll talk about what the fit would be. Okay, so I'm back, and I just want to show you that what I have here is I have the velocity values plotted against the time values. And remember that you should always put the units, so I'm going to write in seconds over here, and over here the units are meters, or I'm sorry, inches per second. And when you look at the data, you could see that it does follow a periodic pattern, and you could say that this might be characterized by a sinusoidal function, which is a sine or cosine function. And so the first thing that we do when we once you graph the data and you realize that you might use this function to model it, is you have to decide, are you going to use a sine or cosine function? So I'm going to just decide to use a general sine function. And in doing so, remember the first step that we always do is we should try to draw through the data what that function would look like. So I kind of see here that I have a function that's going up and down, kind of like a sine wave, right? So it looks like a kind of like a sine wave where you have the upward and downward concavity. And now I'm going to draw just an estimate for where I feel the midline is for the function. So I'm going to draw a line through where I think the midline should be. And remember, this is like a rough guesstimate of where the midline should be compared to the highs and lows of the function. So I want to make sure the midline is balanced so that the amplitudes are the same for how much it goes up and down from the middle. I'm going to write midline just like we've done in the other problems, and I'll write y equals, it looks like the midline for this will be about 7.5, and it looks like my amplitude is going to be from 7.5 to 10. It looks like my amplitude is going to be equal to 2.5. So, what we did before was we talked about how we're trying to fill in all the blanks for the sine function. And we already have two of them filled in. We have 2.5. We know it's a sine function. We need to figure out what bx plus c is. And we know what the midline is at 7.5. So now what we need to do is we need to figure out, as we talked about in when we graphed these or found the functions the other day in class, we need to figure out what the period is. So the period, the way we can go about and do that is we can just figure out from crest to crest how much time goes by. And in this case, it looks like it was from, I would say 17.5 seconds to 50 seconds. And so my period would be 32.5 seconds. Now I need to figure out what my starting point would be for my sine function. And I'm just going to pick up the first location where the sine function starts. So my starting point is going to be at 10 seconds. So working with my period and the starting point, I can figure out my B and C value. So what we do from here is, remember that the period is equal to 2 pi over B. Because the period was 32.5 seconds, we can calculate our B value. B is just going to equal 2 pi divided by 32.5. And my C value is going to be found by, remember, for the starting point. So this is the B value calculation. For the C part of the calculation, we said that the starting point is equal to negative c over b. And because we picked a starting point of 10 seconds, we're going to put 10 seconds in here. That's going to equal c value, which is the phase angle, divided by our frequency, which was, now this is going to be the complicated part, 2 pi over 32.5. When we cross multiply that, we get c equal to 20, because 2 pi times 10 is 20 pi, divided by 32.5, and you can figure out what that decimal would be, and it's negative. So my final result for this function, and you can verify this using Desmos, is going to be the velocity as a function of time is going to be 2.5 sine of 20 pi over, that's a c value. This is 2 pi over 32.5 t. I'm switching this to a time-based function, so I'm just like doing a substitution for x and t, minus 20 pi over 32.5 plus 7.5. So this will be the trig function that will work for this data to better model this data. So here, let me just move this out of the way, move this down here, and oops, I need to really figure out how to, and that would be our final result for the velocity function. That would model that data. So hopefully this helps you, and we'll be doing more problems in class tomorrow on this. So if you have any questions, please comment on the video or save your comments for class. Thank you.